In this video, we're going to discuss CRA models for decimal addition with unlike place values. So this is just where the decimals and at different place values. So we have 27 hundredths, and we want to add 9 tenths to that. So what we want to really highlight here and reiterate is the meaning of each of these place values. Right, so if we have 27 hundredths, we can think of this as 2 tenths and 7 hundredths. We have 2 tenths and 7 hundredths. And again, this model is based on the assumption that this larger square, what we normally use for 100, that is equal to 1. And if we're looking at the 9 tenths, right, again, we have 9 of something, but what do we have? It's 9 tenths, so it'll be these long strips, okay? So we want to make sure that students aren't adding the 9 and the 7 together, because that'll be a common error once we get to the standard algorithm here. So if we want to add these together, right, we have 7 hundredths. We're not going to add any hundredths to this group of 7 hundredths, so this is just going to say 7 hundredths. Then we have 9 tenths, and we have 2 tenths, so we're just going to add these together. So we have 11. We can't write 11 in that one place value. Right, so 10 of these will need to be, right, traded or exchanged for a 1, right? This is equal to 1 in our example. Okay, so now I've added those all together. We don't have any place values that have too many pieces. We have 1, and then we have a tenth, and then we have 7 hundredths. So 1 and 17 hundredths. Okay, so that'll be our concrete model. And representational model. And we'll just be drawings that go along with the base 10 blocks as one of our one option we can use for representational model. So again, since we're not going to, right, we want to add these together, so we want to combine these. We just have these 7 hundredths, so those are just going to stay the exact same. So we have those 7 hundredths. So I'm gonna do this on the second line down here. So these I'm just gonna, let's give myself some room here. So those are just going to say as is, because I'm not going to add any hundredths to that. So again, I want to combine these. Right, so I have 2 tenths, and then I have 9 tenths over here. So let's just we'll take this one. Right, so these are going to turn into, right, that's 10 tenths, and 10 tenths is equal to 1. So this is going to turn into that 1. Okay, so then if we're looking, we have that full 1. Here we still have this tenth that's left over, and then again we have those 7 hundredths, so we have 1 and 17 hundredths. And then the abstract model that we'll generally use when we have unlike denominators is the standard algorithm. Okay, so the standard algorithm for decimal addition is the exact same algorithm as whole number addition. We just need to pay special attention to our decimal point, and we have to align those vertically. We'll kind of explain why that is. Okay, so a common error, because students are going to be so used to using the standard algorithm for whole numbers where they're aligning that furthest right digit. So this is going to be a common error. Okay, they're just used to aligning those digits to the right. But here you can see this would mean we're adding, oh, this should be a 7, sorry. This would mean, if we're just going to use this algorithm, we would be adding 7 hundredths and 9 tenths. So we'd be adding different size parts. We don't want to do that. So we have to make sure that we're not using, we don't want to use this. Okay, we have to make sure that we're aligning this decimal point vertically. So here it's not aligned vertically. So in this algorithm, we need to make sure that we align this vertically. So it just means it's stacked on top of each other. And the reason that we need to do that is because that will ensure that we're adding the same size parts. Okay, so just to show again our concrete model. And we have our 2700s there. So this incorrect model over here would have these 9/10 over in this column. Right, so we don't want to combine those because we're not talking about the same size parts there even. Okay, so this should not be aligned this way. It should be aligned with the 2 and the 9 vertically because they're both tenths. They're both talking about this size part. Okay. So then we just move through the algorithm in the exact same way. Sometimes we'll put zeros in here if students need that to be a little more clear. Okay, so if you want, you can kind of put a 0 in there. I'm just going to put a dotted one. Okay, but that's just so students might recognize that if we have 9/10, that means we don't have any hundredths. Okay, so 7 hundredths plus 0 hundredths will just be 7. And then here we have the 2 tenths plus the 9 tenths. So that will be 11 tenths. Okay, so 10 of those tenths will be regrouped into one whole or 1/1. And then the other tenth, right, will just stay a tenth. There, okay. And then here we have our 1 plus 0 ones again. Okay. And then as far as where to put the decimal point, right, this will always just stay vertical all the way through this problem. And again, you can kind of picture it as, you know, these are our columns in our place value mat. Right, so those are our columns. So that's why this decimal point is going to stay the same going down, is because that's that separation point between the ones and then our fractional portions here. Okay. So again, concrete model, base 10 blocks to be common with the place value mat, especially for when we have unlike denominators, so we can really highlight that the 7 and the 9 should not be added together because those are hundredths, which are these smaller pieces. And these are tenths, which are the larger pieces there. And then representation will be drawings that are aligned with the base 10 blocks, and then the abstract model we'll generally use for this is going to be this standard algorithm.